Hello everyone! So today I'm going to talk to you about finding the equations of both a sine and cosine wave given its graph. Let's start with the general form for sine and cosine equations. We have y equals a sine b of x minus c plus d. The same goes for cosine. What do all these letters mean? A is the amplitude, or the vertical stretch factor. B is the horizontal stretch factor. C is the left or right shift, and D is the up or down shift. Here's a visual example of this. If we have our parent graph y equals sine of x, this is what the graph looks like. Now let's add our a value, or our amplitude. Normally our a value is 1. As we increase our a value, you'll notice the graph gets stretched out, almost as if something is pulling it up. And the distance from the center of the graph, in this case the x-axis, to the peak or the valley also becomes larger. Going the opposite direction, it goes smaller. Now I want you to notice what happens when our a value becomes negative. Specifically, look at this part right here. See, when a is negative, this part is below the x-axis. When it's positive, it's above the x-axis. Let's go on to our b, or our horizontal stretch factor. Normally our b value is 1. As b increases, the graph gets shrunken down like an accordion. There's more ups and downs in a shorter amount of time. This means the graph is going faster. If we go the opposite way, our graph is going slower. Same thing happens when b becomes negative. This part right here goes below the x-axis. Let's move on to our c value, or our left or right shift. When c is positive, the whole entire graph moves to the right. When c is negative, the whole entire graph moves to the left. Now when I say c is positive, I just mean this part right here. Even though it says minus 1.2, that doesn't mean you move to the left, you move to the right. And lastly, let's do our d value, or our up or down shift. Plus d. When d is positive, the whole graph shifts upward. And when d is negative, the graph shifts downward. Now let's apply this to find the equation of a sinusoidal graph. Find the equation of the graph in terms of sine and cosine. Here's the general form again. Let's do the parts that are the same. Y equals sine, cosine. I'm actually going to start with our d value, or the up or down shift, because it's easiest to find. The graph hits a low point when y equals 0, and the graph hits a high point when y equals 4. The d value happens to be the middle of the graph, so we want to find the average of the low point 0, the high point 4. To find the average, we add the two together and then divide by 2. 0 plus 4 is 4, divided by 2 is 2, so that means the center of our graph is at y equals 2, which means the d value is positive 2 for both. The amplitude is the distance from the middle of a graph to the peak or the valley. Now, always pay attention to the scaling of the graph. On this one, each box is worth 1/2. If you just counted the number of squares, you would get an incorrect a value. Our center is at 2, so if we count up, we get 1, 2. That means our amplitude is 2 for both. The b value comes from the formula pb equals 2 pi. In the parent graph, the normal length of one cycle is 2 pi. We want to convert that using this formula to match our current graph. We're trying to find the b value. In order to get the b value, we need the p, which is the period, or the length of one cycle. A cycle can be a top to a top, or bottom to a bottom, or middle to a middle. They're all the same length, so it doesn't matter which one you choose. For no good reason, I'm going to start in the middle. Let's make this our starting point. It is at the point negative 0.25. I'm going to leave off the pi for now, so it's easier to work with. The end of our cycle is at dot 5, which is 1, 2, 3, 4, 5, right here at 0.15. To find the period, we need to know the distance between the two dots. The distance from this dot to 0 is 0.25. The distance from 0 to this dot is 0.15. You don't just subtract the two numbers, more like add the absolute value of them. So the total distance is 0.25 plus 0.15, which equals 0.4, or 2/5. This is our p value. Don't forget to write the pi back in. We want to solve for b by multiplying both sides by the reciprocal. The reciprocal of 2/5 pi is 5/2 pi. These two cancel out. When you simplify, you get b equals 5. Lastly, we need to find the c value. This is where the two graphs differ. There could be many solutions for the left or right shift. Sine graphs start in the middle, so we could use this point, or this point, or this point, and so on. Since we already figured out this dot, let's use that as our c value. As a fraction, this is negative 1/4 pi. It is the opposite when we write it in our equation. We would have x plus pi over 4. And since the curve starts below the center line, we know our a value has to be negative. For cosine, we either need to pick top or bottom. I'm going to pick this one right here. It is at positive 0.05 pi. It is the opposite, so in our equation, we write x minus 0.05 pi. You could convert this to a fraction if you wanted. Normally, cosine starts at the peak and travels down, so our a value stays positive. Now, sometimes you don't have easy numbers to work with. Here's a new graph. Y equals sine, cosine. Let's start with the d value. The graph has a low point at y equals -7 and a high point at y equals 3. -7 plus 3 is -4. Divided by 2 is -2. That's the d value. The a value is 1, 2, 3, 4, 5. Now onto the b value. This is where it gets a little tricky. Before, you could choose any place for the cycle. 2 tops, 2 bottoms, 2 middles. But now you'll see that the tops and the bottoms are in between 2 squares. We don't want to guess what those are, so to get the most accurate answer, we should choose 2 middle dots, since those land exactly on a square. Let's start here. Each box is worth 1/4 pi, so this dot is at 3/4. The end of the cycle is at dot 5, which is 1, 2, 3, 4, 5, right here, at 13/4. The total distance is found by subtracting 13/4 and 3/4. We can subtract here since both dots are positive. If we use these two dots, then we would do what we did in the previous problem. 13 minus 3 is 10, so we get 10/4 or 5/2. Don't forget the pi. Multiply both sides by the reciprocal, 2/5. These cancel out. When we simplify, we get b equals 4/5. Lastly, let's figure out the c value. For sine, let's use one of these points we already found. This dot is at positive 3/4, so in our equation, we would write x minus 3 pi over 4. The graph starts above the center, so the a value remains positive. Now for cosine, we need a top or bottom. Since those values are not pretty, we need to average 2 dots to find the exact value. If we average these 2 dots, we get this dot, which is at 2 pi. By averaging these 2 dots, we get the bottom number. By averaging these 2 dots, we get the top number. Doesn't matter which one you choose. I'm going to choose these two. 2 is also 8/4. 8/4 plus 13/4 is 21/4. Divided by 2 is 21/8, which is here. In our equation, we write x minus 21 pi over 8. Since that dot is at a valley and travels up, the a value is negative. That's all I have for today. Thanks for watching.